Today we are going to discuss about the parallelogram law of vector addition. So already it's written here that two vectors are represented both in magnitude and direction by the two adjacent sides of a parallelogram drawn from a point. Then the resultant vector is represented both in magnitude and direction by the diagonal of the parallelogram passing through the same point. So what is the meaning of this? First I will explain that thing. Think this is an object here. This one is object here. Now someone is pulling the object in this direction, another one is pulling the object in this direction. So someone is pulling the object in this direction, another one is pulling the object in this direction. So now you tell me which direction the object will go. The object will go in this direction. In this way, the object will go in this way. So this is the directions like this way. An object will go in this direction, in this direction. Okay. So like this way we can draw a parallelogram. So how we'll explain the thing. First we'll draw a parallelogram in this way. So this is one vector. You can give the name OA vector. And another vector is there, that is the OB vector. OB vector which is working in this direction. You can give the name P vector. This one is P vector, capital P vector. This one is Q vector. So what is the resultant vector? I told you if two vectors are working, one vector is working in this direction, other is working in this direction, then what is given here? See, if the two vectors are represented both in magnitude and direction by the two adjacent sides of a parallelogram. So first we'll make it as a parallelogram. So this is the parallelogram. This is the parallelogram. The two adjacent sides of a parallelogram. Okay. Then the resultant vector. Okay, not vectors. Vectors will be represented both in magnitude and direction by the diagonal of the parallelogram. So this is the diagonal. This is the diagonal of the parallelogram. This one, like this. It will work. Okay. So this is your resultant vector. This can be written as R. The P, Q and R. So as this is P vector, this is Q vector, this one is Q. So I already know that we can move the Q in this way because both the lines are parallel in parallelogram. So this vector is also, this is also Q vector. This side is also Q, right? Q. And this is P, so this is also P. This is also P. This Q, this one is Q, this one is Q. Okay, this one is R, this one is Q, this is P, and this is also P. Now we have to determine the analytical method. We have to find out the magnitude of the R vector. We'll use the same procedure what we did in the triangle law of vector addition. The same thing we'll do. First we'll draw one perpendicular here like this way. Perpendicular. Now remember what I told you, the angle between the two vectors. So P and Q angle is this one, is theta. And the angle between resultant and P, this one is alpha. Okay. So as this is theta, so this will be also theta, and this is 90-degree angle. That already you know. A, this one is C, and this is O, and this one is D. This is the name given. This is D, this is C. Now again, the same procedure we'll do. First we'll take the triangle, this triangle, OCD triangle. We'll do it, triangle OCD. So you'll use the Pythagoras theorem. Then we'll write O square is equal to OD square. OC square is equal to OD square plus CD square using Pythagoras. Now OC square is equal to, OD means what? OA plus AD. OA plus AD whole square plus CD square. So OC square is equal to OA square plus AD square plus 2 OA AD plus CD square. Okay. Now from this triangle, from the triangle ACD triangle, we can find out sin theta and cos theta. We already know this one, I explained in the. So CD is equal to what? And AD is equal to find out. So if I do cos theta is equal to base by hypotenuse, means AD by AC. So AD will be how much? It will be AC cos theta. AC means what? Q vector. So Q vector mod, that is magnitude, and then cos theta. So AD you found over. Similarly, CD is equal to how much? Q vector mod sin theta. Why? Because sin theta is equal to perpendicular by hypotenuse. So this thing you have to use here. OC is equal to R vector mod. OA means what? P vector mod. AD is what? Q vector cos square theta. OA is what? P. 2 P vector, AD is Q vector cos theta, plus CD is what? Q vector square sin square theta. Now you from these two things, from this and this will take common, Q vector will take common. So we'll get R vector square is equal to P vector square plus, if we take Q vector common, cos square theta plus sin square theta is equal to 1. So square plus 2 P Q cos theta. Okay, so this is separate. So now you can write R is equal to root over Q square plus Q square plus 2 P Q cos theta. So that is the magnitude. Same type of angles, tan alpha. If you want to find out the angle between the two vectors, find it. Tan alpha is equal to perpendicular by base, means CD by OD. CD is what? CD means Q vector sin theta. OD is what? OP plus AD. So P vector plus AD means Q cos theta. So this thing already explained. CD means OD means what? OD means OP plus AD. Okay, so not writing this one actually. So you can write down. So what formula we learned? Special case. Okay. The special case is when theta is equal to 0 degree. Then what will happen? 0 degree means both the vectors are parallel to each other. So write down R is equal to how much? Formula root over P square plus Q square plus 2PQ cos 0. What is the value of cos 0? Cos 0 is 1. So you can write root over Q square plus Q square plus 2PQ. That means P plus Q whole square. So R is equal to root over P plus Q whole square means P plus Q. That is the thing. Remember this one, cos 0 degree is equal to 1. Next one is, what is the angle that time? Angle will be tan alpha is equal to Q sin 0 by P plus Q cos 0, right? Q sin 0 by P plus Q cos 0. Sin 0 means 0, that means 0. So alpha will be 0 degree. So alpha is equal to 0. Okay, that is the when theta is equal to how much? 0 degree. Now when theta is equal to, this is a special one number case, 2. Theta is equal to 180 degree. Then what will happen? Again we'll use the formula r is equal to root of r square plus q square plus 2pq cos 180 degree. Value of cos 180 is -1. So we'll let p square plus q square minus 2pq. That means p minus q whole square. So r is equal to root over p minus q whole square, which is nothing but p minus q. Okay. Now this angle, that time tan alpha is equal to q sin 180 by p plus q cos 180 degree. Sin 180 is 0 again. Okay. So then you can write 0. Angle is 0. So alpha is equal to 0. Alpha is equal to 0 degree. Okay. Next one is when theta is equal to 90 degree. Then what will happen? So when theta is equal to 90 degree. Then r is equal to root over p square plus q square plus 2pq cos 90. Cos 90 is 0. So root over p square plus q square. And tan alpha is equal to q sin 90 by p plus q cos 90. So you can write q by p. Okay. So alpha is equal to, you can write tan inverse q by p. Okay. So these are the special cases, very useful cases. You can use it several places when you do numericals. So now I'm going to discuss the another thing that is called the polygon law of vector addition. So this part will get over. Polygon law. What does it tells? That if the number of vectors are represented both in magnitude and direction by the sides of a polygon. So write down this one. If a number of vectors are represented both in magnitude and direction by the sides of a polygon. Taken in same order, then the resultant vector is represented both in magnitude and direction by the closing side of the polygon taken in opposite order. So what is the meaning of this? Suppose I'll draw a polygon, you can understand this one. So this is the polygon. Four on the side, we put 5. Okay. The polygon, and this one also one side, closing side is this, the polygon. 1 2 3 4 5 6 sides. Okay, polygons. Now I can give the name of the sides here. So this is A, B, C, D, E and F. Now what is said, if the number of vectors are represented both in magnitude and direction by the sides of a polygon taken in the same order, that means this will be a vector, this is a vector, suppose this is a vector, then different vector will place in the a vector, then b vector, this is a b vector, this one is c vector, and this is d vector, this one is a vector, sorry, e vector. Okay, this is the vector is finished. Now how many type of vectors are there already? You just put according to the polygons different sides. Then the remaining side, this is the last side, the closing side will be represented. Will tell you the what? The resultant. This is the resultant will come here. This is your resultant vector, R vector. This is your R vector. That is the meaning of the law. Now how we will find out this? Suppose this is a vector, this is b vector. We'll use the triangle law. I'll make it as a triangle, small triangle, this one. So what about this vector? This vector will be a vector plus b vector. A vector plus b vector. Okay. Now if I join this one, what will happen to this vector? A vector plus b vector plus c vector. So this and this are same order. Spin a vector plus b vector plus c vector. Okay. Now you can see this vector and this vector in the same order. Again you can use the triangle law. So this vector will be a vector plus b vector plus c vector plus d vector. Now see this vector and this vector again forming a triangle. So what about r vector? R vector will be what? A vector plus b vector plus c vector plus d vector plus c vector. So a vector, b vector, c vector plus d vector plus e vector. Okay, this is the r vector. That is the resultant vector. That is what is called that the resultant. What is written here? The resultant vector is represented both in magnitude and direction by the closing side of a polygon taken in opposite order. This is came in opposite order. You can understand this one. So all the vectors are in the same order, but the result came in the opposite order. So these are one type of vector additions will be useful some cases. Okay. So today is up to this. So next class we'll continue with the subtraction of vectors. Okay. So thank you very much.